Good evening, everybody. This is data communication second presentation regarding wireless communication. Previously, we have completed one data communication, such basic data communication presentation, and you will understand how powerful is wireless communication comparatively to those basics. So I am Nuwan. So let's start. So as the overview, I will hope discussing these topics. What is IEEE wireless standards? We already know what is IEEE. So media access control regarding the wireless aspects, and Wi-Fi, Bluetooth, RFID, Zigbee, hotspot technologies, wireless sensor networks, and wireless security protocols, and antenna theory in MIMO. So those are the things that I am going to discuss through this presentation. So let's start. So why we have to have that kind of wireless standards? So we already know that standard is for globally maintaining same thing, the rules and regulations, the same thing developing by various kind of developers in various kind of areas, or various kind of globally in various kind of areas. So the reason is for wireless standards also. So it is described on IEEE standard 802. So because of these things, so it has location flexibility, because it is not location based, tightly coupled on location. So it is, you have flexibility about the location. So you can move anywhere here and there. So that is why the mobility is called, and the productivity. So compared to the wired communication, so wired communication have to have, so think about the wiring, about a network. So you have to have work with the lines of the UTP lines, or those kind of communication lines, and it will be less productive than the wireless. So wireless, you don't have any kind of that connection. So it is like the and the expandability. So comparatively to wired, so if another hop or another node came into the network, so you have to do so many things to configure and set up, and adding that node to the network. So in wireless communication, so it is very easy, the easy of expandability. So let me discuss about some examples. So there are some various different kind of wireless technologies. So the Institute of Electrical and Electronic Engineers, IEEE, the professional association. So it is described this for an example. So IEEE 802.11 is for wireless LAN, local area network. So these kind of examples. So wireless personal area networks, WPAN. So it is 802.15. So likewise, it is describing each. There is each version number, and there is a technological thing. So going forward, so the subversions. So here the wireless LAN describing about IEEE 802.11a, 5 GHz up to 54 Mbps. Likewise, the QoS, quality of service enhancement. Likewise, there are some releases on IEEE side about the standard of this technology. So this is kind of one example. And the specification of 802.11a, that is regarding to this, the first point. So the frequency bandwidth and the bandwidth of the channel, and the modulation scheme, the BPSK, bipolar, and the QAM, ECU, amplitude modulation techniques, and the channel architecture is using OFDM. We have discussed these things in our previous presentation, the orthogonal frequency division multiplexing thing, and the maximum data rate and the range of how the technology is working area, and the maximum transmit power is this of 100 milliwatt. So that is the basic things of the standards regarding to IEEE. So other than IEEE, there are some other standards also, IET. So let's discuss about those things in future in this presentation. So the media access control also. So you already know. So when different parties using the same channel, so there may be collisions. The media should be controlled somehow to avoid or prevent those collisions and make the communication smoothly. So in as we discussed in wired communication, we discuss Aloha and those things. So in wired communication also, there are some methods. So this first 3 points we have already discussed, like frequency division, frequency division, multiple access, time division, multiple access, and code division, multiple access. The two variations, CSMA-CD and CSMA-CA. So those things we have discussed in our video one. So I mentioned the link that video, so you can refer for more details on that. And the last things, space division, multiple access, we didn't discuss in that thing. So what is space division multiple access is? So it is we call it as the space division multiple access or spatial division multiple access. It's like a technology which is using that MIMO architecture, multiple input and multiple output, and because of it mostly using wireless and satellites. So we will discuss about MIMO in the at the end of this presentation. So the features are like all users can communicate at the same time using the same channel. That is one advantage, and that is completely free from the interferences because of that satellite and wireless communication technology. And a single satellite, if you are using single satellite, it can communicate with more satellite receivers of the same frequency. You can use in the same frequency and you can communicate with more satellite receivers. And it is a word called spot beam antennas. The directional spot beam antennas are used, and hence the base station in SDMA can track a moving user. That means what is the spot beam is that is a satellite signal that is specially concentrated in power, so that it will cover only a limited geographic area on the Earth. So that is targeting Earth stations in an intended reception area, can properly receive a satellite signal. So that is the spot beam satellite. So that is one advantage, and the other thing is that it is controlled the radiated energy for each user in the space. So that those are the space division multiple access things. So let's moving into the hot topic in these days, the Li-Fi. So Li-Fi means can you think about what is Li-Fi? So Li-Fi is it is like a brother of Wi-Fi. So is Li-Fi means the light fidelity. So what is light fidelity? So light fidelity is a wireless optical networking technology that uses LEDs, that means light emitting diodes, for data transmission. So that is the breakthrough technology in these days. So there are some specification in Li-Fi, like the frequency is 10,000 times 10,000 times frequency spectrum of the radio, like radio. So it is very speed because of it's using light, and the maximum coverage range, it is 10 meters, and it is using full duplex. That means it can communicate both ways, two-way communication, and data rate is near 1 Gbps, and standard body is the IEEE. So IEEE, you can refer those Li-Fi standard rated things. So we use it because it's high capacity, and efficiency is very high, and security is very high, and because of that it's no interferences. So Security high means that since that light cannot go through walls and those things, so hacker unable to hack in in another part of the in another part. So he have to come to that station if he want to hack it. So because of that, it is very secured. So normally it's underwater communication using this Li-Fi, because we can detect like the vibration information in underwater. That means in sea level. So in tsunami, in underwater tsunami detection, so you can use those things for detecting and preventing. So, and the hospital and healthcare using this technology. This technology is under research at the moment, but it is emerging technology, and we can use it also for smart lighting in our cities. So those are the things related into Li-Fi. So the Li-Fi the architecture as the figure depicted. So there is architecture going on here, because so what we want a communication is a binary system, 1 and 0, right? So the light bulb we can turn on and turn off. So repeatedly it provides a potential communication ones and zeros. That's what we need. So LEDs are the high brightness lights. That is why they are using LEDs, and flickering those lights on and off 1,000 times per second. Can you imagine it? So it is make a binary logic. When, for an example, when the LED is on, it transmits 1, and the LED is off, it transmits 0. So the transmission happening, that optical signal is detected and received by a solid state photodiode at the user equipment receiver. So photodiode is using for receiving, and the Li-Fi that operate in a system that utilize a controller to transmit data along with the control the LED light bulb. That controller also controlled and varied rate at which the LED switch on and off. So which is a critical component in data transmission with Wi-Fi, because Li-Fi, because it is the controlling the variation rate, right? That the content that is streamed and encoded is in the lamp driver. So you have to have a lamp driver, and it is connected to the light bulb, LED light bulb. So the light bulb then also contains the microchip that converts the digital data into light waves and transmit. So along with the lamp driver, the microchip is also critical component to the switching of the LED for data transmission. So altogether, so this is what happening, the process of the Li-Fi communication. So there are a lot of components which is receiving light detecting controllers. So at the end, once receiver received the photo detector, the streams are amplified. You have to amplify the streams and decode it into the binary, and you can use them into a node. So that is how Li-Fi worked. So it is very emerging technology. So then let's move into the Bluetooth. So you all heard about Bluetooth, right? So Bluetooth also is a wireless technology. So it is technology standard, so for exchanging data between fixed and mobile devices over short distance, right? Using short wavelength, ultra high frequency radio waves in the industrial and scientific, and you can use the medical radio bands from 2.4 I think to 2.485 gigahertz. So it is also using for building personal area networks. So there are the frequency is 2.4 let's say gigahertz, and maximum coverage is 100 meters, and it has duplex full duplex communication, two-way communication, and data rate is 22 Mbps. So standard is IEEE. So it has lot of features like less power consumption and less complication comparatively to other protocols, the technologies, let's say. And it is very cheaper rates you can buy it. And the robustness is one thing. The application side, so you already experienced those applications. I am pretty sure about that. You have used the wireless headset and wireless MP3 players, phone networks, and you linking your laptop or your PC to printers, okay, keyboard, wireless mouses, wireless keyboards. So those are the things in practical real world application using Bluetooth. So it is a very important thing. So in Bluetooth, there is evaluation I have bringing it to here. So there is not just one night technology. So it is 2004 it is initiated, and now 2016. Now we are in 2019. So there are some versions released, and there are some features related to that versions. You can see this. I am not going to explain deep in these things. Then the second, the architecture I have described here. That is the important thing. So for describing it, I have used two ways of describing it. So it can be described in topological based, and it can be explained in frame and protocol based. So let's discuss in first in topological base. So in Bluetooth, there are two famous topologies using in Piconet and Scatanet. So actually, Scatanet is a combination of Piconet. So let's first the building block is Piconet. So let's first go into the Piconet. What is the Piconet means? So I have missed the slide. Very sorry about that. So this is the Piconet topological architecture. So Piconet, this is a Bluetooth network that we have known it. So it contains a slave and master relationship. So there are primary or master nodes, and there are slave nodes. So you have to have 7 secondary nodes or slave nodes. Maximum you can use 7. Other than that you cannot use. So because of that, it have 8 active nodes, right? 1 is a master, and 7 are 7 slaves or stations, we can say. The distance is 10 meters, right? So the important things are, so only one primary or master station in each Piconet. You cannot have to have more than one master nodes in one Piconet. The communication between the master to slave can be one-to-one communication or one-to-many communication. The all communication in between the master and slaves, slave to slave, is not possible. That means you can communicate only master-slave communication. Okay, slave to slave communication you cannot perform. So those are the important thing in Piconets. Okay. So yeah, I missed one thing. So in addition to 7 active slave stations, a Piconet can have up to 225 park nodes. So there is a state called park state. So parks nodes are secondary or slave stations, as we mentioned, and cannot take a part of communication until it is moved from park state to active state. You can have, but you have to shift the state active to active state from the park state, right? For active Piconet, it is 7 slaves and 1 master. That is the summary. Okay. So then move into the Scatanet. I have mentioned Scatanet is a combination of Piconets. As you can see now, there are 2 Piconets, and there is a 1 computer, a laptop computer, which is a bridge, working as a bridge. We call it a slave bridge. Okay. So scatter net is a combination of piconets. A slave in one piconet can act as a master in another piconet. Doesn't matter. So such a station or node can receive messages from the master in the first piconet and deliver the message to its slave to other piconet. So it is active as a master in the second piconet. So this node is called, as the figure mentioned, bridge slave. I mentioned it, slave bridge, but it should be bridge slave. So the station can be member of two piconets. Okay. It is you cannot use two masters, two piconets, one master. Okay, one master should be for one piconet. Let me explain it. It will be confused. So a station cannot be a master in two piconets. That is the thing. So then we go into backward. So this is what I want to explain. Frame and protocol explanation. This is the frame and the protocol. The left hand side is I think it is the protocol. Yeah, it is the protocol. And right hand side is the frame. Bluetooth frame format. So it does, though it is in this is for actually a model, layered model, as you can see, like OSI and TCP/IP. So it is for explanation. So this, as you can see, it is divided into physical layer, data link layer, middleware layer, and application layer. So the Bluetooth standard has many protocols that are organized into different layers, as you can see. So the layer structure is not follow any OSI model or TCP/IP model. So it has its own model. Okay. So this is the model it uses. So basically, I will explain basic functions of these layers. So the radio layer, the bottom layer, is for the physical layer of the OSI model. It's related to physical layer of the OSI, and it is for it is deal with ratio transmission and modulation. Okay, and the baseband layer is for it is equivalent for MAC layer in LANs. It is equivalent. Okay, don't miss out the words. It is equivalent, not it is UC. It is equivalent, and it is it is using TDMA for multiplexing things, and the other middlewares and application layer is for application things, and middleware is used for those audio and other logic control things, service discovery and telephony and RF communication, link manager. So those are very deep things to describe. So I am not going to describe those things. Then let's move into the frame format. So frame, as you can see, there is access port and there is a header part and there is a data part. Let me explain it right to left. So data part is it is the messaging part. I mean, contains the data or the control information coming from upper layers, right? So it uses, as mentioned, 0 to 2744 bits. And the header part for 54 bits it uses, and it divided into address type, FAS bits, and checksum. So what is those things? So what is that checksum? We know that checksum is for error control, error detection and correction. So error detection actually, it is 8-bit field for detect errors in the header, right? Then what is for FAS? So F is for it is for flow control. That is why they put F there. And if it is set to 1, it means the device is unable to receive more frames. Right? If it is 0, it can receive more frames. A means it is for acknowledgement, and S means it is for detect retransmission as stop and wait protocol is used, right? One bit is sufficient for that. That means this kind of a sequence number of the frame to detect retransmission. Whether you have retransmission, it is 1. Whether you don't have retransmission, it is 0. And the type, it uses 4 bits for that. So it is for actually identifies the type of data coming from the upper layers. What type of data? And the address, you know what is the address, right? So it is for broadcast communication for primary to all secondaries. Those are the address. Access code 72 bits is using. It is called contains synchronization bits and identifies what is the master. So those are the things in these are very deep topics, but I have to describe in few less time. The time factor is more important. So let's move. So this RFID then. So what is RFID? RFID is for what? Radio frequency identification. So what is radio frequency identification? So it is it uses the electromagnetic fields to automatically identify and track tags attached to objects. So you know that when you are using shopping malls and there are tags attached to your clothes, so they are removing at the counters. You have experienced those things. So that is the RFID tag. So it is basically, technically, it is contain electronically stored information, and radio frequency that identifier, it is containing we call it a reader. So RFID reader and RFID tag which is attached to an object that we want to identify. The reader is going to read it. Okay, the reader, what it does is reader continuously send radio waves towards the air, and the object with the tag is in the range of the reader. Then RFID used to retransmit its feedback to the reader, and the tag is categorized as active tag. That means it uses its own power supply, and there are called passive tags. Let's discuss in the future. The next slides I will explain those things. Passive means it does not using power supply, and there are other type is semi-passive. So the reader, as I mentioned, the reader consists of the RFID signal generator inside. The signal generator and the microcontroller both. So it is then operating the frequency ranges as low frequency, high frequency and ultra high frequency. So those things we can discuss. So let's because these things, so this is the RFID picture. So you can use it for trash and lamping and the benches and for trees. So there's a smart cities. So the frequency ranges in RFID, as I mentioned, it uses low frequency, high frequency and ultra high frequency, and coverage range is 3 meters to 180 meters, and it has only one-way communication, and data rates is varies. The low is 8 kbps and maximum is 604 kbps, and standard body is not IEEE. It is ETSI, that means European Telecommunication Standard Institute, and ISO, International Standard Organization. The features, what are the features? So it is the scanning range and multiple scanning ability, and speed and convenience is the features. And the application you have already experienced is like product line management, patient ID management, logistic and warehouse management, and asset tracking and parking management. These there are more, but those are the things I have mentioned here. So this is the thing I have mentioned, that there should be antenna and the reader is there. So the tag is there, reader is sending the radio waves, and the tag is giving its feedback when it's come to its area. Then it will be detected. So that's how it working. That means here the types I have mentioned, that active system is there, passive system, and battery assisted system. So these are the frequency ranges. So the active RFID means the tag power source is internal. It is internal inside into the tag. Passive is it is energy transmission from the reader via RF. In active RFID, the tag battery, they are using tag battery, but passive is not using. Battery assisted is also using. So likewise, there are some data or specification related to each one. Another example is communication range, let's say. So the active RFID has long range communication. That means 100 meters or more. But the passive is very short, so it is up to 10 meters. So battery assisted is moderate range, so it have somewhat up to 100 meters also. So likewise, there are some variations. So let's then move into the NFC. What is NFC? So what is RFID and what is NFC? So NFC, near field communication. Here NFC operational modes is there. I will explain what is NFC. So NFC is, so you know RFID, so you heard that. So it is using radio waves. So NFC is kind of a specialized subset within the family of RFID. That is means this is specially using a high frequency RFID. Let's say that is a branch of RFID. Means it is operated 13.56 megahertz frequency. So the NFC, as you can see that the operational modes, it is used as a tag reader writer, peer-to-peer you can communicate within devices, and card emulation you can use. So NFC is also IEC and ISO standard body, and it has also features like easy network access, and data sharing is very easy. So the connected and unconnected is, it's very easy. The ability to connect and unconnect, you can do that. That means the authority or the power give to users, and it works everywhere. So that is our features. So application, you know, credit card payments and e-ticketing and booking, personalized usage and wearable and retails. So some are not using in Sri Lanka, but most of them are using. You have seen those things. So then there are a lot of technologies, right, in wireless. I have told you in the starting the presentation, not like wired. So there are so many technologies. So Zigbee. So Zigbee is I mentioned it is the specification suit, and it is high level communication protocol to create personal area networks. Like, so it is actually frequency 2.4 gigahertz, and it will coverage maximally approximately for 3 kilometers, and two-way communication it got, and 20 kbps to 250 kbps data rates they are there. And so it is used for industrial automation, home automation, smart metering, and smart grid monitoring. They are used Zigbee. Then there are famous Zigbee topologies, star topology and mesh topology. and a cluster tree. So based on your application, you can use one of these topologies for your application. Okay. Then the hotspot. What is hotspot? Wi-Fi hotspot. You are using it in your phones. I know when the internet is going off, you using this hotspot and connect to the internet. So it is hotspot. Hotspot is a physical location where people may obtain internet access. Right? They are using your phone to access internet. So it is typically using Wi-Fi technology. Right? So and via wireless network, wireless local area network. Router connected to the internet service provider that phone is used for that. So I will describe this little bit. The frequency is at 2.4 gigahertz and maximum coverage range is 100 meters, and it has also two-way communication. There are different kind of data rates: 11 Mbps, 54 Mbps, and 600 Mbps and 1.3 Gbps. And IEEE is there are various versions in IEEE like IEEE 802.11d, G, N, A, C, and AD. So those are the variations, and it is very convenient and has mobility and increased productivity and deployment easiness. These features of Wi-Fi hotspot, and it is also using for home automation, and you are using it connecting to the internet very easy and extended of LANs. This one. So then let's move into the wireless sensor network. So I have put a definition using Wikipedia. The wireless sensor network refers to a group of spatial dispersed and dedicated sensors for monitoring and recording the physical condition of an environment and organizing the collected data at the central location. It uses radio waves to get connected to the internet to another network. So there are some keywords there. Spatially dispersed. It is not isolation, distributing manner sensors are put in, and they are monitoring and they are connected to a network. So they are isolated but interconnected. So most of the time IoT, Internet of Things, is one aspect of this WSA. So Internet of Things also communicating different devices and doing data analytical processing. That is a different thing, but there is a base that helping for IoT based on this technology, wireless sensor network. It is also using for, I will discuss about those things because it is used for in transportation and logistics and smart buildings like indoor climate control and healthcare and health monitoring and medical diagnosis, and the environmental monitoring is one thing I have experienced because it is used for like flooding things. So river level, what is a river level, and they are sensing the river level and sending data like let's see this example. Let's assume those things are in flood to detect flooding things. So this will tell that sink is that those data are all pumped into the sink, and sink will collect those things and push into the internet, that let's say a cloud, and then cloud can process it using data analytics and machine learning and anything. So this sensor data can monitor also whether a sensor goes down, then you can replace it. So there are interconnected software for that, but the sensing node is sensing the environmental data and it sends those data into the sink, not sending at once. You can see there is a path, so there is a network, there are sensor nodes and there are routing nodes. So they are using both nodes and sending data. So that is very important thing. This is also using military applications like DRAPA. And the wireless security protocol, the next topic. So it is another topic that we have to discuss. So in here there are some words I have mentioned: WEP, WPA, WPA2, WPA3. So that is words of protocols. So WEP, the wired equivalent privacy, Wi-Fi protected access WPA, Wi-Fi protected access to WPA2 and WPA3. So what is those antenna theory and those here I use antenna theory. First I describe this before going to the antenna theory. We come into last, the wireless protocol, the wireless equivalent protocol, the WEP. So it is first the innovation of the security standard 802.11. So it is easily hacked and it is using 24-bit initialization vector. So it is weak authentication. So you should not use that. That is the recommendation. So how it is work is it uses RP4, stream, cipher, and 64 and 128-bit keys and static master key. And so WPA, it called Wi-Fi protected access, and it is the interim standard, and it is address major WEP flows, and it is backward compatible and with web devices, and it has two modes: personal mode and enterprise mode. So this retains use of RC4 but at longer IVs and 256-bit keys. Each client gets new keys with TKIP enterprise mode. So it is if someone asks you to use it, yes, but only if WPA2 is not available. That is the recommendation. And WPA2 currently standard never hardware and ensure advanced encryption. It doesn't affect performance. So also has personal and enterprise modes also, and it is replace RC4 and TKIP with an AES algorithm for stronger authentication and encryption. So it is the recommendation to use. So WPA3 is also advanced and it is recommendation for use. And finally, the antenna theory, the MIMO. When we starting our presentation, we discussed in MIMO, right? MIMO means multiple input, multiple output. So multiple input technology is radio communication technology or RF technology, and it uses multiple antennas to make use of reflected signals to provide gains in channel robustness and throughput. So as you can see in the figure, there are antennas. You have seen these antennas attached to some top of buildings. So these are antennas. So there are multiple outputs and multiple inputs. So transmitters, for an example here in picture, transmitters with 4 antenna elements, and it has radio transmission path, and it receives with 2 antenna elements likewise. So it can target it and it can tune up, mixing lot of inputs and creating the radiation effect to targeting your mobiles. So the diversity modes use that advantage. So diversity modes separated into 3 kind of categories in antenna, MIMO antenna. So time diversity, frequency diversity, and space diversity. So time diversity means it is using a message that may be transmitted in a different time. For example, using different time slots and channel coding. And frequency diversity means its form of diversity uses different frequencies. So it may be in form of using different channels or technologies such as a spread spectrum or OFDM. And space diversity, used for broadest sense of the definition, is used as the basis of environment. It uses antennas located in different positions to take advantages of the different radio paths that exist in difficult terrestrial environment. So those are the three diversity modes and give advantages of MIMO. So that is the end of the presentation. Hope you guys understand something, gain something in that presentation. So keep in touch with me. My mail is there and my Twitter address is there. So please comment on my presentation, feedbacks, and thank you for all. Have a nice day.